Welcome to Source Code, where we unpack the engineering behind ambitious ideas.
Hmm.
Today, we're looking at this puzzle of global logistics and design, and it's centered on a piece of hardware called the TR Pro 01. On the surface, it's a machine for refining minerals,
Right.
but it's really a key designed to unlock a multi-billion-dollar supply chain.
It's a fantastic topic, Alex. So the TR Pro 01, it belongs to a company we've been following for a bit, Terra Ledger.
Yeah,
They want to refine critical minerals like tantalum, right at the source, in the Democratic Republic of Congo. The TR Pro 01 is their tool to do it.
okay.
And its design is totally dictated by its incredible journey.
Okay, so let's frame this as a challenge for our listeners. Imagine you're the lead engineer. The mission: build a compact refinery in New Hampshire and get it to a remote site in Masisi, DRC.
Wow.
And the site is what, 11 miles from the Rubaya mine, one of the world's top sources of tantalum. I mean, where do you even begin?
You begin by looking at a map and calling a freight forwarder, because your design isn't about chemistry first.
Right.
It's about transportation. The first constraint is the ocean.
Hmm.
Your entire refinery has to be modular, broken down into pieces that can fit neatly into standard 40-foot shipping containers.
So it's like designing a house that has to be shipped in a dozen separate boxes.
Exactly.
The maximum length for any single piece is about 12 meters. Width is 2.4 meters, but that's the easy part, right?
Yeah,
That just gets you to the port.
exactly. The sea voyage from, say, Boston to Dar es Salaam in Tanzania is kind of the calm before the storm.
Okay.
The real test is the next 1,500 kilometers overland. The roads are a mix of paved highways, rough tracks, and, as Terra Ledger's own document warns,
Oh boy.
they're roads that can become completely impassable in the rain.
So now the 40-foot container that was your friend on the ocean is just a box.
It's just a box.
You have to unload it. The real question becomes, what's the single heaviest or largest component inside that box?
And this is the heart of the design. The optimal dimension isn't one number. It's a balance of factors dictated by that overland route. You're limited by the capacity of local cranes, payload of available trucks, the turning radius of a tight corner.
Right.
The loading bearing capacity of a small bridge is less like shipping a car and more like shipping, a very expensive, very heavy set of surgical tools, that you have to reassemble in the middle of a field.
And they have to be reassembled on a site with no existing infrastructure.
None.
Terra Ledger's plan literally includes building an independent electrical grid just to power the facility, so the design can't require complex, high-tech assembly tools
Exactly.
that you can't even get there.
It's the ultimate design for reality. It's not about creating the most efficient refinery in a lab.
Yeah,
It's about creating the most effective refinery that can be deployed in Masisi. That practicality, that focus on the entire life cycle from factory to field.
right.
That's what makes the TR Pro 01 so brilliant. It's what makes the whole venture possible.
It basically transforms the concept from a simple export to a full-scale deployment of U.S. industrial standards in a box. When you see their budget, like $500,000 for the prototype and a 10% shipping cost of $50,000, you understand that the shipping is a fundamental part of the product itself.
It's a system, not just a machine. And that system is what will let them produce that first pilot ton of tantalum pentoxide
The proof.
and prove that this audacious New Hampshire to Goma pipeline can actually work.
It's a powerful reminder that sometimes the most elegant engineering solution isn't the most complex, but the one that best understands its environment. Now, here's a question we'd like you to think about. The TR Pro 01 is engineered to fit the existing, difficult infrastructure of the region. But as Terra Ledger scales up to deploy, hundreds of these units,
Yeah.
at what point does it become more effective to invest in improving the infrastructure itself, the roads, the bridges, rather than just engineering these clever workarounds? Like, where is that tipping point between adoption to the world and, changing it?